In this video, we're going to look at a Onshape parametric CAD document which will allow you to create cat box fin designed model rocket fins. For you to utilize this resource, you'll need to create a free account in Onshape. I have done that, and basically you would go to cad.onshape.com, which is where you can sign up for the account. The free account limits you to a small number of documents. I think it's 2 or 3. Now, just so you know, a document can actually hold a lot of parts. So unlike some CAD systems where each part is a single document, Onshape parts can actually hold a lot. And we're actually going to see the document I'm going to show you will have 2 parts in it, and you can go much greater than that. But in any event, once you've logged in, and because I've accessed this resource before, it showed up in my history here, you'll come up and it will be blank, basically. I'm going to show you what happens if you click on this link, tinyurl.com/boxfins. Okay, click on this. Okay, we bring up a new tab. It redirects us, and we are now in CAT's box fin design shared. Okay, and it will say this document is view only, but it has been made public, which will allow you to make a copy. So what I'm going to do is click on the make a copy to edit, which will allow you to adjust to your particular parameters. Okay, so I'll come here. It will come up with the name -copy. You can change it to anything you like. I'm just going to accept that. And now the version that was earlier has been replaced with my version that has complete copy edit access rights to it. Now, just to go across this, across the bottom are various tabs. Okay, this is called a part studio where parts reside, but the design is based on RockSim's trapezoidal fin variables. So what I've done is I've kind of showed what the variables look like in RockSim. For example, you have the fin thickness, the root chord, the tip chord. This is for trapezoidal designs. The sweep angle, which is the angle of the leading edge. 0 would be a straight front fin. Okay, and then semi-span, which is kind of the height of the fins as it goes here. So these are the variables which are utilized. And when you go to the Trap Box Fin Part Studio, you will see there are the variables listed, and in addition to that is also going to be a body tube. So I'm going to come up here, I'll double click, and you can, by default, the dimensional units are in inches, but you can add units. For example, 18 millimeter. If I was using an 18 millimeter tube, that would be this. Let me go and indicate that I was going to use a 30 millimeter tube, so I can put 30 millimeters in, or the inch value, either one's from that. Accept the change with the green box. Okay, fin thickness is here. Root chord. Okay, basically how high is the fin where it attaches. I'm just going to demonstrate putting in 1.5. If I just put 1.5, press enter, it will automatically take it as inches, the default unit. I accept that. My tip chord, okay, I can change this to say 1 inch. Okay, in here, sweep angle. Okay, if, just to show you, if I put 0 in, the fin will be straight in the leading edge. Okay, if I put a negative angle in, the fin would actually be sweeping forward. I'm going to go back to, say, 45 degrees. Okay, and incidentally, here for angles, the default unit happens to be degrees. And the semi-span, basically the distance from here outward, is controlled here. So maybe I'll make this 1.5 inches to show a change. I accept that. So if you want to fit things, here is your view. Isometric will zoom it out, and you can see what your fin now looks like. To see what the fin looks like in an assembly, you would generate 4 of these fins. Okay, here is an assembly. which shows all fins wrapped around a cylinder that is the body tube that you've specified. So this fin arrangement, the fins are mounted on the outside. The little tabs and holes have been provided so that the fins can lock in, making the assembly process a little bit easier. If you're doing these by hand, you could simply ignore cutting out the square holes in the straight and then just glue them on that way. We happen to have access to a laser cutter, so putting the holes and tabs on actually works out to be fairly easy. Now, once you have your fin set to the parameters that you'd like, come over to Box Fin Pattern. This is where we generate the drawing. Now, one of the things about drawings is that they have to be updated. You see this little yellow button? Update this from the workspace. Click over here. Okay, the fin will now be adjusted. If I tape F for fit, it will automatically zoom out and give me the full size for the view here. Okay, if I wanted to print this fin, and incidentally this is a full-size pattern, scale 1:1, to print, you would go up to these three lines, click here, and say print. It would then bring you up in a print window. This is an 8.5 by 11 sheet. You could then go send it to your particular printer using this command over here. Okay, so you can see the printers that are available that are on this. So I'm going to cancel all of that. I can close this view from here. If you wish to download this as a DXF file for, say, a laser cutter, go to the tab, right-click, and say Export, and you can choose PDF or DXF, okay, in here, and choose whichever sheet you want. For example, current sheet is the one that we'd have. Export, download, press the export button, and what will happen is it will give us a notification when the file actually can be downloaded. A little window will pop up, which we should see in a moment. Here it is. Okay, I'm just going to go to my desktop. It will utilize Trap Box Fin Pattern, the name of this tab. I just hit save, and the file has now been downloaded. Okay, so that's how you can create a DXF file, or you can print. In addition to the trapezoidal fins, we have elliptical fins. So utilizing the elliptical fin geometry, we'll have thickness, root chord, and semi-span. So coming over to the elliptical box fin, again, we can do whatever we like here. Double click to change our body. Maybe I'm going to say 1.25 inches this time. I'll accept that. My root chord defaults at 1.25. Maybe I'll make it 1.5 inches here. Okay, and if I wanted my span, say, to be 2 inches, let's just change it so we can work from there. Okay, we now have, okay, and incidentally, I type F for fit, it will automatically zoom out so I can see what my fin looks like. Okay, as we go from there, just as with the other, there is elliptical box fin assembly, so you can see what the fins would look like going around the body tube, and then your pattern. Click on this, you'll see the little yellow circle will show up. Press on update, and we have our updated fin. I press F, it zooms out so that you can get it. Again, you can print or download as needed. Okay, that concludes this video on how to use the CAT's box fin design Onshape CAD resource.